Good afternoon, everybody. Welcome to the second lecture of the lecture series on business mathematics and statistics. I'd like to welcome you all again. And those who were with us on the last week also went through a very brief introduction onto how this subject is being structured. And also, most importantly, we discussed two main things. That is, one is we need to gain knowledge on this subject matter, and on the other hand, we are looking at completing uh, the requirements or the expectation of the examiner of this subject and complete your IABF level at your earliest, and then move on with your rest of the subjects. Having said that, we discussed a few basic things on very basic introduction into statistics and a few important concepts on data, uh, types of data, sources of data, so on and so forth. So before we start the today's class, I'll just take a very quick minute and let me just have a very brief discussion with you. We'll take not more than 4 or 5 minutes onto the important aspects what we discussed during last lecture. Okay. Um, I hope you have the handouts with you. Uh, First of all, we discuss some basic introduction into statistics, statistical data, uh, and usage of statistics, and how you can use these techniques into convert the raw data into management information. Uh, Importantly, before we move on to the users and techniques, we discussed that sometimes statistics could be misrepresentative. It could give you some misjudging ideas or the audience some misleading statements, so that you might not really feel an unbiased output has been given to your viewer kind of scenarios. So we discussed certain instances of selecting uh, not enough sample for your studies and selecting not enough data points, or selecting a biased sample, leading sample for your study and deriving conclusions. So those were some of the uh, misrepresentations of statistical data. And then we moved on to identifying raw data versus information. Uh, we wanted to segregate, say, what sort of items or observations which we can classify them as raw data, and then on the other hand we process them using some techniques and convert them to so-called information. So we discussed some of the example. For example, this number of rainfalls in given 10 days could be raw data, and if you use the word average rainfall in the past 10 days, we call it as information kind of examples. We discussed the types of data can be segregated into two branches, qualitative and quantitative. Qualitative, again, we discussed some two deviations, nominal and ordinal, based on the characteristics of bucketing using the nature or a particular characteristic of that data. For example, gender or ethnicity or nation. On the other hand, the ordinal data are again qualitative, but we could cluster them into different baskets in an orderly manner. One of the best examples that we discussed was customer satisfaction, or level of pain, or level of anything, which you will stratify them into different baskets, basket 1, basket 2, 3, and 4, and 5, so that you could represent them for management information purposes. On the other hand, we discussed on the qualitative data, uh, there were more on quantitative data as well. Merely quantitative data are where you can identify the measurable component in a numerical oriented way, or a number, or your device will give you an exact number or an integer or a decimal point, where you will see that particular data point will be easily classified into where it will fit on the data set. The quantitative data we discuss can be broadly divided into two branches, discrete and continuous. Continuous data is where you will have uh, many more decimal points or many more fractions or many more points in between a certain measurement. One good example would be if we discuss the temperature of a particular person. If your measuring device is giving you only two decimal points, you might see 98.12. But if you have a even more stringent device, you could identify as 98.123 or 1235, so on and so forth. On the other hand, discrete data is where your observations or your data set will be limited to a preset of discrete numbers. One of the most significantly evident category would be numerical or integer values. For example, number of planes that landed on a particular airport on a given day. It will be 98, 99, 100, 103, so on and so forth. Even it can take decimal points also. For example, that tricky example which we discussed on the stock market prices, if you could remember, there you might see 10.10, 10.20, 10.30, so on and so forth are the values that can take place. No, importantly, no in between decimal points. That's how your data set is defined. So we went on discussing the two types, qualitative and quantitative, their advantages, disadvantages, their uses, and again we came to the last section on the sources of data, which examiner is sometimes very keen to test your knowledge on. It's very easy. There are only a few things to discuss. The sources can be either primary sources or secondary sources. It's very easy to keep these things in mind. The word itself elaborates you how the data source is being distinguished. The name itself, primary data, is where you will be gathering data yourself firsthand based on research, based on data collection. On the other hand, secondary data is where you will be using already collected set of data uh, by somebody or previously or by an institute or any person prior to your research being conducted. The best example would be statistical data disseminated by Central Bank, Department of Census and Statistics, Colombo Stock Exchange, so on and so forth. And then we discussed some of the advantages and disadvantages. Particularly, we were keen on identifying the cost, easiness, and accuracy and unbiasedness of the sources of primary and secondary. Make sure, students, that when you write answers to the questions, write as much as you can, be elaborative as much as you can, because if you use more points in a bullet form, the examiner will identify that you are keen on your subject areas. And merely if you just write primary data is that is coming from primary sources and secondary data is somebody already has gathered it, that might not really be sufficient. You might need to write a bit of an elaborative, descriptive answer. Okay. Finally, we stopped the last week's session with the wording of population and sample, where we briefly identified that the entire set of data could be identified with the name population. In the statistics jargon, what we are discussing under this module, we will name it as capital N. And when we want to conduct a study on that collected statistics, we tend to select a sample. And on our jargon, we will call it as simple N for the sample. And we stopped with the last slide on the previous session, where we identified that there can be interesting sampling techniques that we can use to define that simple N from the capital N for us to effectively do and study. So all the other 11, other 10 out of these 11 subject areas that we are discussing this course, under this course, we will be deriving with the assumption that we have taken a sample from a data set. Shall we calculate mean, median, and mode? Or we have taken a data set from a sample, and now we need to identify with 95% of probability what will that particular data point will be 13 or 14, so on and so forth. So now this section that we are discussing today will not give you numerical sums. It's very important to understand. We will be discussing the past paper questions towards the end of this session. And when we look into some of the very recent last couple of 4 or 5 years of past papers, you could identify that this area is being heavily tested on the qualitative aspects. You will not be required to write any answers on computations, rather merely explain and describe your knowledge on uh, the definitions, or on the other hand, let's say compare and contrast certain aspects, and on the other hand, compare two different methods and explain what are the similarities and differences, so on and so forth. So that's the whole idea of today's session. So we'll be starting with the sampling procedure, and we will go through 8 different sampling methods, sorry, 8 different sampling methods, and identify the individual characteristics in a way that you should be able to answer in a qualitative manner when the examiner asks you to explain. One good example would be your examiner will ask you a question like this. Could you do a compare and contrast between systematic sampling and snowball sampling? So then you are expected to explain him in a way of nice, concise manner the theory that we are discussing today. Okay, I hope that will give you a brief understanding on what we are going to discuss today. And with that introduction, let's go through the today's session. Before I start the session, if you have any questions that is coming from last week or any doubts, we could take a moment and discuss them. Am I audible and visible to everybody? Okay, I see some responses. Thank you. Okay, so let's start with the lecture 2 on the first lesson out of the 11 subject areas on sampling methods. This will be the content for the day. We will mostly going through the qualities of these sampling methods and their respective usages, their limitations, and some of the easiest example for you to remember, and which will give you some opportunity to write precise, exact examples in the examination. The sampling methods, what we are discussing today, are broadly classified into 2 areas. First, we will discuss non-probabilistic sampling techniques. The word itself gives you some idea. Okay, that means those sampling techniques will be not using probabilistic oriented models to select our sample. On the second section, we will be discussing the probabilistic sampling. That would be the contra side, or the other side of the non-probabilistic sampling, where we will select the simple n from the capital N using some probability oriented methodologies. Okay. Lastly, we will discuss some of the possible issues with sampling. Now, if you could recall that at the very first instance, or the last week, we discussed one interesting example. We have 70 students in the class, and we need to assess their advanced level mathematics knowledge, or rather the ordinary level mathematics knowledge, for us to get an understanding on whether the given students are very fluent or not fluent in mathematics. If you could recall, we used some of these categorizing techniques and identified 25 students out of 75 students. Okay. Now that is the very good example. Now that is a very good example where you could see, rather than be interviewing all the 75 students and asking them questions, we selected a subset and we gathered data from that subset. So that is all about sampling you select a smaller proportion of the given bigger entire population, capital N, for you to study and derive into conclusions. But then again, students, you will understand that when you, given the chance that if you could access all 75 students and question them, that would be the best thing to do. You will not omit anybody. The previous week's example was that we had 75 students and then we needed to uh, question them. So on my discussion, I explained that talking to 75 students might take hours. It will be cumbersome. Students will not feel comfortable to give me answers, so on and so forth. So because of that, we selected a smaller set and then we went on with our questionnaire. But provided that if you could access all the 75 students, and given that you do not have all these limitations, I would suggest that it is best to speak to the entire population if it is possible. But why we are going through this sampling is merely because that it is not possible. Sometimes due to geographical limitations, sometimes due to not accessibility to your sample due to various reasons. So under section 4, where we have the possible issues with sampling, we will be discussing that due to selecting the simple N from the capital N, what sort of problems that we'll be facing with and how to minimize them. Students, let's be very mindful here. Examiner is very keen to test your knowledge also in that last section. He will ask this set of questions again and again on identifying some of the issues on sampling. And like in previous week, we will discuss and wind up the session with some of the real world past paper questions that is being tested in the IBSL curriculum for the last couple of years. Let's move on with the session. Yeah. So this chart will depict you the sampling procedure or selecting that smaller population could be classified into different types of sampling techniques. If you are asking a question that is this 8 is a universal thing, I would say no. There can be many more other sampling techniques, and there can be again, like we discussed in last week, this is not only classification of sampling into their respective buckets for the discussion. There could be many other ways, but these are most prominent and most evident and mostly used by statisticians around the world for their routine work. Okay. So if we take a very brief deep dive into the sampling procedures, the non-probabilistic would be where you will be selecting the simple n not based on probability. We discussed this previously. So classically, there won't be, when the word probability comes into picture, random selection will be the next thing which comes to our mind that says that, okay, we seem to be trying to give some equal opportunity for everybody to be present in our simple N. But on the other side, the non-probabilistic mean there won't be any random selection, but some educated selections. It's very important to understand. Educated or intentional selections will be coming under the non-probabilistic sampling area. As explained in this slide, you are not essential to know information about the population. Why does it say so? Because if we are going to use probabilistic sampling on our other aspect of the discussion, for us to give some equal opportunity to everybody, we need to know the word everybody. In our last example in the class, our population was that 75 students in the classroom. That is a capital N. So we knew that those 75 students are the set of data points which we need to evaluate and understand a certain qualitative characteristic. Okay, but on non-probabilistic sampling, this is where you might not essentially know the limit of your capital N, or not essentially know all the characteristics or information related to the capital N. For example, if I choose a word like, instead of the 75 students example, if I use, okay, let's try to assess the mathematics knowledge of the A-level students who are just completing their advanced level examination on this year. Now, if we went through the education system, you might find an exact number, let's say 150,000 or 1.5 million. But you, as the researcher, do you think that you know the exact number of students that you are going to interview? Like, 75 student example, which you knew that the number is 75. But if you take that population of Sri Lankan A-level students who are just completing their A-level, let's take that as the capital N or the population, you might find it a bit difficult to know where the capital N are segregated or scattered geographically, where they are living, or how are we going to reach them. You might miss some, isn't that so? The system who collects that data and depicts that there will be 1.5 million students, the system might also miss some people, and system might double count some people. So you might not essentially know the information on the capital N or the population that you are going to collect data. This is where the non-probabilistic sampling becomes very handy or very useful. You might see that you may select some educated guesses and select some people or data points or responses from the data which is accessible to you for the researcher. Now, in that instance, we are fundamentally doing something called a bias test, because we know that there may be 1.5 million students in Sri Lanka who is completing A-level examination, but we can't reach them all. So instead, we will select, let's say, 10 students from each district and try to build up our sample. But there may be students or densities or concentrations that you are not focusing if we just went through non-probabilistic sampling, because you are not aware of the information of the entire population. So with that introduction, let's look into the broader definition on the non-probabilistic sampling. Okay, let's go through the slides. This is a sampling method where it is not possible to specify the probability that any person or any unit on which the survey is based will be included in the sample. That means we cannot give a guarantee that everybody will be given equal chance or opportunity to be eligible to selected to the sample. It doesn't necessarily mean that we give equal probability, but it gives an indication that it gives an equal opportunity to stand up and be our data point. These are some of the key advantages. You could select the sample in a purposive manner. That means purposely you can select the set of people you want or the researcher wants. And also, it will enable us to reach members in the population in a more flexible manner. Now, in our class example of 1.5 million A-level completed students. If you cannot reach the southern part of the island, and if you can only reach the western province and the central province, for that example, you can all reach them and omit the other set of people merely because of the non-accessibility, if the example says so. Okay. So as mentioned here, the main disadvantage is that it is difficult to make a valid estimate about the total population because the sample selected is not representative, it is biased. Because we knew that there are many data points out there, but due to various reasons, due to easiness, due to cost constraints, due to physical limitations, we are not in a position to reach and collect the data. So that is the key disadvantage in all these 4 non-probabilistic sampling methods that we are going to discuss. Having said that, let us start discussing the 4 non-probabilistic sampling methods one by one with examples and try to understand how they can be used in real world. Once again, let me just browse back to the set of sampling methods that we are discussing. We are still here. We are under the non-probabilistic sampling techniques. We are going to discuss the convenience, judgmental, quota, and snowball sampling to understand how each of these techniques works. Okay. First one we are discussing, we call it the convenience sampling. Now students, if you carefully look at the wording of these techniques, in some instances you will easy, even at the examination, if you are not really aware exactly as to what this sampling method trying to evaluate the simple n from the capital N, still using the name or the technique, the name used in the technique, you could derive a basic understanding. The convenience word itself says that the researcher or you are going to select a sample based on your easiness or the accessibility or flexibility. Isn't that so? Look at this definition. Members of the population are chosen based on their relative ease of access. Analysis can be conducted by what was convenient, not by random. Okay. This is also called as haphazard or accidental sampling. Let's carefully see this example, which is explaining the diagram in the given slides. Okay. The red color man here is the researcher. And if you could see the set of people that he has selected for his sample, which is mentioned on this blue line where I'm taking my cursor here, it's based on his immediate access. Isn't that so? He's very close to all these other people, the green person here and 2 other green persons and the purple person here. So it appears that he has selected these 4 out of this, let's assume that we have 20 people here. It appears that he has selected these 4 people for his sample using the convenience sampling methods. But immediately you could see, as given in this example itself, no purple figures are included in the sample. So that shows you that using the convenience sampling, you might miss some of the total representation in a given population in an unintentional manner. You might not know, the researcher might not know that there are purple data points in the given population. So unknowingly, he will only select this set of blue and green data points to his sample. But do you think that this is a good sampling method in the first place? I would suggest that it might not be the best method. But In many cases, given the nature of your research, you might have to select the convenience sampling merely because of the easiness of conducting your study or survey or analysis. Let's take a classic example. Uh, Now, you as a researcher or a statistical analyst being asked to conduct a survey like this. Uh, let's try to identify some of the problems faced by uh, workers in tea plantations. Okay, now you want to travel, you want to talk to people, you want to give them some questionnaire and analyze them, but merely because of the geographical difficulties that you see in the upside of the country, you might not really find it very comfortable to select all the places and visit them. It might take you an enormous time to reach them. Instead, if you select one or two hotspot or one or two concentrated places where people gather, where the workers of the tea plantations gather, and if you just go there, you would be able to use some of your data collection techniques and talk to these people and gather the set of data that you want. So you will only focus on one set of or one or couple of locations, which is in the convenience of your choice. But having said that, now can somebody argue that your research is incomplete? Can somebody say that you didn't talk to everybody, you didn't select a best sample out of the entire tea plantation workers population? Can somebody argue? Yes, they can argue. But on the other hand, given the limitations or the focus of your study, you might have to limit to 2 or 3 places and come to conclusions of your study. So that is where convenience sampling is used in the practical world. The second type, what we are discussing under the non-probabilistic sampling here, is the judgmental sampling. This is another form of convenience sampling where the items are handpicked. With educated guesses, you go and handpick them from the accessible population. Researchers select items that are representative of the entire population. A very subjective sampling methods like the previous one that we discussed on the convenience sampling. Similar to this. Let's see the difference. Okay, you have the researcher in between, and this set of data points are your entire population or capital N. You have selected the set of people given in the right hand side of the picture as your simple N or the sample from the population capital N to the sample. Now the difference is in the convenience sampling, you access the data points that is of your convenience or accessibility. Here, you tend to handpick certain selections or data points from your accessible population based on some educated guesses. Sometimes you can call this as expert selection. You're an expert on that particular selection, and based on your expertise, you select a set of data points to be representative in your simple N or sample. Okay. One good example that I can discuss with you is, let's say we want to select the best set of musicians from an orchestra. So you, as the researcher, might not really have the idea of how each of these instrument players are playing the instruments and who would be the best set of instrument players. Okay, so you might invite one of these maestros or an expert or a composer in music and mm, show your orchestra, set of instrument players to him, and ask him to select the best violin player out of 5 violin players and best cello player out of the 2 or 3 cello players and best trumpet player from the 10 trumpet players. So we use some of this expert selection or judgment in these sampling methods to define our simple n from the capital N. So let me reiterate again. The difference between the convenience and judgmental would be in the convenience method, you don't necessarily go for an expert selection. Okay, you might take some data points which is just close to your reach or convenience. In here, judgmental sampling, you use some of the expert selection or an consultant's input here to select your sample from the given population. So instead of in our previous example, instead of we choosing a maestro for our study, but if you select yourself a researcher without any knowledge, that might not really be the judgmental sampling. So you have to be, or the researcher has to be having some expertism or having some idea on the immediately reachable population to be included into your simple N or the sample. Okay. The third one, this is very interesting and important and can be a bit tricky also. We call it as the quota sampling. The word quota gives you an idea that, okay, in our simple N or in our smaller sample that we are going to select, we are going to be giving some quota or a proportionately proportionate chances to the items in the population to be selected for a sample. Let's see what the slide says. This is similar to stratified sampling. That is another technique that we are going to discuss in a little while under the probabilistic sampling methods. This is similar to stratified sampling, where the population is divided into mutually exclusive subsets. Okay, the word mutually exclusive is something that we are going to heavily use in our third or fourth lecture series that is on probability. It says that your quotas or your sub segments of this entire population cannot have crossing or intersecting or some common characteristics that one item can be sitting on both of these places. It cannot be this case. There can be some statistical data when you want to evaluate certain qualities. You might tend to classify them into 2 buckets in the same time. But in this sampling technique, if you find such data, this is not the best sampling method to be followed in such instances. Again, let's continue on the slides. So we are tend to give some, we are trying to divide our population into mutually exclusive subsets. That means in a given subset, you cannot have the same characteristics. One data point cannot sit on 2 subsets in the same time. Okay. Then judgment is used to, again important, judgment is used to choose the items from each stratum based on a specified proportions. That means, unlike a random selection, you try to put the population into different buckets, and again use your judgment and select some data points to be represented in simple N. It says the difference between the stratified, that is something which we didn't discuss at this point, but in a little while. The difference between stratified and quota is where stratified requires random sampling for each strata, while quota does not require so. Now, this is a very important point to keep a mark on. And stratified sampling will be discussed in this, the contra side of this. But on the quota sampling, once you select a quota for a particular subset, let's say 3 items or 4 items or 5 items, you do not necessarily need to use some probabilistic methods or random selections or some organized selections. It doesn't necessarily need so. Rather, based on your educated guesses, based on your judgment, you can select your sample. Okay. Now look at the example given here, where you have the population of males and females based on their ethnicity. So the given example says 50% of male personnel are in the population and 50% female. So let's just have a glance through and calculate how many items are here in this population. We could see there are 10 males and 10 females. So altogether we are talking about 20 items in our population. It's limited to 20. The second characteristic given here is that 70% of the population is white and 30% is black. So the example itself depicts that from the 10 males and 10 females, 70% would be white and the rest would be black. Okay. So we have the population like this. Now we are going to use the quota sampling and try to define our simple name for the sample. Let's say we want to select 4 items in our sample, as the given example says. So when we are going to select 4, it is ideal to first give a quota 50% to males and 50% to females. Okay. And again, now here, do we use any probabilistic methods or random selection? It doesn't necessarily. So the moment you select 50% males and 50% females, you know some other characteristic also, which is the white or black, the skin color that we're discussing here. Okay. So based on that knowledge, or based on your education on that this population contains people of both of these skin colors, you will select one white personnel and one black personnel in the male population. And similarly, select one black and select one white from the female population. There you have a nice sample of 4 out of the 20, where a quota is given to each of these stratums or each of these buckets or each of these subsets based on your knowledge. Okay. But there again, if you look at the selected sample, you might not essentially see the representation of the gender distribution. You might see the representation of the gender distribution, but not the race or the skin color distribution here. Because for you to select that 70% and 30% selection is not really evident in our quotas, isn't that so? Let me reiterate. You could see that there are 10 males and 10 females. So your sample also has the same percentage, 50-50, 50% males and 50% females. But the second characteristic that we are discussing here is not being adapted, is not being catered in the quota sampling because of the difficulty. I mean, you might only have 4 places in your sample, so you tend to go with the educated guess or your judgment to select the 4 people like shown in this example. So the most important thing I reiterate that it is not a random selection but an educated selection that we are discussing under the quota sampling. That would be the only difference that we are going to discuss when we come to the stratified sampling against this. Okay. Last one that we are going to discuss under the non-probabilistic sampling, we call as the snowball sampling. Again, something easy to remember, like a snowball. What do you call, we might not really see or experience snow here in Sri Lanka, but you could see that in some of these video materials which is available online, you could see that people can create snowballs using the snow that is just lying there. But if you look at an example like an avalanche or some sort of a huge pile of ice being coming down, you might see that it's not the exact same amount of quantum that is coming down at once. Rather, it tends to come down slowly and gradually gather weight, gradually gather more snowballs, gradually gather more items and fill the snowball and become big towards the end of the journey of the snowball. The sampling technique that we are discussing here, titled snowball sampling, have the exact same idea. I'll show you. A non-probability sampling method where existing study subjects recruit future subjects from among their acquaintance. What is that idea that we're trying to discuss here? That is, you have to select first couple of points from, let's say, based on your accessibility or based on your reachability, you select first couple of points. Then you tend to ask that data point to recruit me more data points and give me more data to be selected in my sample. See this given example. This sample group grows like a rolling snowball where the first respondent refers to a friend. Where the first respondent refers to a friend, and then that friend also refers to another friend, and so on. Like an example of a snowball. Okay. When I was thinking some good examples for this snowball sampling, I came across this interesting thing. I mean, we all may have encountered that sometimes we have been forwarded with a link to support somebody on a survey. Let's say I have a friend who is doing an MBA and he's doing some research or a survey on fisheries industry in Sri Lanka. Could you take 5 minutes of your precious time and fill this thing for me? Also, you might say, if you could find some more suitable candidates, kindly forward that so that our friend who is doing the research will have more data points. That's one of the classic examples where you can see snowball sampling is being used. That means the subject that we are selecting in the first instance will be responsible of recommending the second and the third and so on and so forth. Again, is this an ideal sampling technique? It might not necessarily be. Because you as the researcher does not have the ability or the controllability of selecting the second tier or the third tier. I mean, it will just grow on. So, for example, once you select your sample of data responses for your study, you might not necessarily know that whether the data that you have collected are being genuinely filled by the anticipated set of people. For example, in that example, which we discussed a moment ago, that your friend is doing an MBA, you're trying to support him by spreading the link of his online survey. Okay, you might feel it. Okay, you might not necessarily have an idea on the fisheries industry, but you will feel it. And to support your researcher, you will forward that link to 10 more people, which 7 out of that 10 might not necessarily have an idea or any idea rather on the fisheries industry. And he or she will just randomly select some answers and fill the questionnaire. So when the data comes to the researcher, there will be a lot of errors and noises and limitations or sometimes non-responses, sometimes biased or partial responses in the selected data. Why? Because at the third and second and fourth and so on and so forth, those tiers are not really under the control of the researcher to select his sample. Okay, that's about it. That's on the non-probabilistic sampling. Let's do a quick recap. These are the 4 types that we discuss under the non-probabilistic sampling: the convenience, judgmental, sorry, quota, and snowball. Convenience is very easy to remember. It is the convenience or the easiness of the researcher to reach for data points. Judgmental is use your expert judgment or use somebody else's expert judgment to select a set of data points for your sample from the population. Quota sampling is where you, based on your prior knowledge on the population, you can give a quota to be representative in the selected sample for the population. Snowball is the last one that we discussed. That is where a set of data being collected in the first iteration, second iteration, third tier, fourth tier, you will grow your sample like a snowball without your control, but from the recommendation of the second, third, and fourth tiers, so on and so forth. So students, now all these sampling techniques, if you recap, comes under non-probabilistic sampling. Why? We do not tend to give an equal opportunity to the items in the population to be selected in the sample. Why? Again, because we have no choice. Because we do not necessarily know the information or the entire set of information or all the characteristics of the population. Now, if you know information on the population, you can use the probabilistic sampling methods that we are going to discuss under next section. We could recognize that certain over or under allocation could be occurred at the non-probabilistic sampling techniques. Isn't that so? So now we want to give some equal probability or a selection chance to the entire set of data in the capital N to be selected to the simple N. Again, not essential to give exact equal P's or exact equal probabilities. It might not be possible in each of these instances, but try your level best to give equal selection opportunity to entire set of N capital to simple N. Okay. The slide says certain items of the population under consideration can be underrepresented or overrepresented. To minimize the above selection bias, target population has to have an equal opportunity for selection. So that is where the probabilistic sampling comes into picture. Let's go through the 4 items that we are going to discuss under probabilistic sampling one by one. Okay. The first one that we are going to discuss here we call it as the simple random sampling. All items of the population under consideration have the chance of being selected, have the probability of being selected. For example, you can use a random number table and pick simple n number of fairly random selections out of the population capital N. For example, it says using a random number table, the second, eighth, etc. items of the population to build the sample. Now, what does this say? Let's look at the given example of these 12 individuals in our population. In this example, we have to select 2 items into our sample from the population of 12 people. So what is this technique that we are going to use? It doesn't have any scientific selection criteria, but purely random. That is the most important thing. Now, how do you ensure that these items are random? Let's say you have 12 students and you don't necessarily know where they are seated, but you want to just select 4 into your sample. Okay. Now, in that instance, one of the easiest things that you can do is just draw a small template of random numbers, or you can draw straws, like in like when you used to play cricket when you were kids. Just have some straws and you draw the highest to the lowest to select the batting order. Likewise, you can use many methods. For example, you can use rand function in Excel, which will give you a random number between the selected values. Or in your calculators, you could use shift and rand key, which will give you a random number between 0 and 1. And you can record that number. So every time that system will ensure that you will be given some random numbers. So if you ask me how we have selected this 2, 5, 8 and 10, I would say there is no any scientific way. It's purely random numbers. So does this random sampling method gives an edge or an advantage for the researcher to select a good sample? I would say yes, to a certain extent. It seems to be a good sampling method. Again, let's focus our bigger picture here. We have capital N, and we want to select the simple N population for our study. Okay. Now, in this given example of 12 students, you might ask, okay, why don't you just go and select all 12 to our study? But let's assume that this number 1, 2 represent thousands, 1,000, 2,000, 3,000. You have 12,000 students here. So you have to select 4,000 out of them for your study. Now, in that example, you will have to go through a random selection, pure random. It can be 1, 2, 3, and 4. That doesn't have necessarily an order. So in my random selection, I've been chosen 2, 5, 8, and 10. But in one of your examples, you might select 3, 4, 5, and 8. Could be anything. So that's the idea of simple random sampling. You have a population. You give an equal opportunity to each and every item to be selected to the sample based on a random number that could be assigned for your study. Now, if you just try to elaborate this example a little further, let's say you want to select 6 out of these 12, what would you do? Use a similar technique. You can use again another random number table and select 12 items. Sorry, 6 items out of the 12, right? So your end or the simple end should be defined here first. For that number of points that you're going to include in the sample, you need to refer to a random number to select the items from the population. So that's the broader idea on the simple random sampling. Okay. The second one, what we're discussing here is the what called systematic sampling. Researcher can determine the sample size, simple N, from the population, capital N, and determine the sampling fraction. This fraction, which is given under the second bullet point, it says the target population divided by required sample size would be the fraction or number that we are going to segregate from point 1 to 2 to 3 and so on and so forth. Look at this example. Sorry, there's a small typo here. This should be an AN. If an airline has 400 passengers and 50 would be the sample size. Now that sample that we're going to select will be 50. Under systematic sampling, it is suggested to pick every 8 passenger on a sequential order to build our sample. Now how does that 8 comes? It's merely 400 being divided by 50. Now, if you could recall the very first example that we discussed on our first class, you could see that we had 75 students, right? In the classroom, we had 75 students. And from these 75 students, if you could recall, the question that I had was that if I randomly just ask somebody to stand up and tell your marks for your ordinary level examination, I might not necessarily get a true and a fair answer. He or she might say, okay, I got an A. The second person also will say, okay, I also got an A. Now you are the third person. Let's say you don't have an A. Still, you might feel it a bit uncomfortable and fraudulently you might say, okay, I also have an A pass. But instead, if you could recall, we used a technique to minimize that problem, right? We put them in a row from 1 to 75, and for that 25 simple N or the sample to be selected, I picked every third person from the first point. So the first person, fourth person, so on and so forth, to be selected for the sample. And then again, I used another random technique. I gave an empty piece of paper to the students and write their mathematics score for their ordinary level examination in whichever place they like. And we are going to ask others to not get it. Okay. That way, we could fairly assume that the set of data that we are getting is more unbiased, more accurate, and free of errors. Because I don't know who has given the responses of A's and B's or C's. It doesn't really matter. Does it matter for me? No. My sole intention was to get an idea of the mathematics knowledge. So am I going to marginalize anybody? No, that's not my requirement. I just need to, let's say, design a question paper or design a course curriculum for the students. So for that, I might need to assess your mathematics knowledge. So students, the example that we are discussing here, systematic sampling, is the exact one that I used in my very first class example. Now in this 400 passengers and 50 sample size, and that you're going to talk to every 8th passenger, if you put them in a row, is where you can use systematic sampling to select your sample. Is this a good technique? Some would say, okay, it fairly seems to be a good technique, but are there limitations? Still there could be limitation. Let's say the 8th person that we are going to randomly select in these passengers is having the exact similar characteristics randomly. Let's say you want to assess whether you are going to eat meat, I mean, you're going to have a meat-oriented meal or a vegetable-oriented meal in your flight. Okay, let's assume that now that is that question. What if every 8th person is a meat lover? I mean, he or she, or a vegetable lover? Then your sample unknowingly will be biased towards the end that you're not expecting. I mean, you might need to have a fairly equally distributed set of 50 personnel, but there may be a chance that out of that 50, at least 35 or 40 will be biased because of the, I mean, because unknowingly 8% can be again coming to a, you know, a probability that you will never expect it to happen. Can we omit that? You can't, because 400 passengers we're just putting in a queue, let's say based on their arrival or based on their ticket row or the number. So those kind of limitations can also be there in the systematic sampling. Okay. Third one that we're going to discuss today under the probabilistic sampling is stratified sampling. Now, students, if you could recall that in the non-probabilistic sampling, we discussed a technique which has similar characteristics to this, right? The difference here we discuss is that whether we are going to do a random selection or not. So in the previous technique, we did not do a random selection, but here we are going to do a random selection. That's the categorical difference. Let's look at the slide. Population should be divided into homogeneous and mutually exclusive groups called strata. Isn't that a similar thing that we do under the non-probabilistic technique? It is. Some of the examples could be age, gender, geographical segment, so on and so forth. Each strata collects samples by simple random sampling or systematic sampling methods. Now, that will be the difference where you will see stratified sampling becomes prominent. Now, look at this given example of these phases of white, red, and green. Let's say this is a set of users, let's say mobile phone users or a particular app users or a particular player of a computer game or a PC game, which you are going to assess their level of satisfaction or happiness. Now, they have given their response to a particular interview question from a Likert scale of 1 to 3. 1, 2, and 3. 1 being, let's say, dissatisfied, this red color segment. 2 would say, let's say, indifferent or not happy, not unhappy either. Comes to the white color segment. And last, number 3 for the happy or the green color segment. Now, these stratas, you have to cluster them based on your prior knowledge. Based on your homogeneous or mutually exclusive groups called stratas has to be defined by you. Now, once you put these observations or data points or people into these strata, strata 1, 2, and 3, then we are going to use a probabilistic oriented sampling technique to select our sampling. The best 2 cases that you can use is simple random sampling. That means from strata 1, from this segment of white color faces here, you are going to use a random number table or a random number generation whatsoever technique that you are comfortable with following, and select 1 or 2 or 3 or number of people that you want to represent in your sample. You do the similar thing into the green segment and the red segment also. Got the segment here. Based on a simple random sampling or systematic sampling, you select items from the specified strata to the simple name or the sample. Now, the quota sampling technique that we used under the probabilistic sampling, non-probabilistic sampling technique prior, you did the exact similar thing, isn't that so? You classified them into different stratas or segments or buckets, and then selected some items. Now, students, the only difference that you can see here is at the selection level. In the quota sampling, we selected the simple n items based on an educated guess in the quota sampling method. But in the stratified sampling, the difference is that to select the simple n from the capital N, you're using a technique based on probability. So you will indirectly give an equal opportunity for the items to be selected in the simple n or the sample. Okay. Yeah. Last one that we are going to discuss under the probabilistic sampling technique is called as the cluster sampling technique. Now this the things that you're going to discuss under cluster, quota, and stratas are seems to be pretty much coming into a similar pattern, isn't it? So you tend to group them or cluster them or give a quota for a selected group of people based on a particular characteristic. But it's very important. Now there are minor differences that will classify these different techniques into distinguished differences of cluster, quota, and strata-based sampling. Let's look at the cluster sampling. We are going to divide the population into groups, clusters, or if you use quota or stratas, I don't mind, and obtain a sample, and obtain a simple random sample of clusters from all possible clusters. Let me repeat it. Divide the population into groups, and obtain a simple random sample of clusters from all possible clusters. Above is called one-stage cluster sampling, while if you conduct another simple random sampling from the selected clusters, it can be defined as two-stage cluster sampling. Look at this given example. Now we have people with their t-shirt color being distinguished from red to green, yellow, blue, and purple. Now let's say these are some sportsmen that has come to watch a sports meet, or some spectators and a mix of house members. Okay. The first step that we are going to follow here is we are going to cluster them based on a selected characteristic. In here, the given example, we have selected the t-shirt color of red, green, and purple, yellow, and blue to cluster them or segregate them from one another. Now again, here also the previous rules valid. That is, you can't have mutually exclusive items or the same item being represented in two clusters if your intention is to use cluster sampling. It's not possible. Your cluster will have to have the similar characteristic that will distinguish them from one cluster to the other. So in previous instances of quota and stratas, what we do is we selected items from each of these clusters or classes or groups for our sample. Okay. But here the difference is we selected entire cluster, entire class, entire group, and take them into our sample. Okay. Let's take a classic example. You want to assess the let's say literacy level of a particular village, let's say a rural village in Sri Lanka. Okay. Now your assignment as a researcher is to go and assess the literacy level of households or people in a rural village. Now in a given house, you might find, okay, there are 3 or 4 or 5, 6 or 7 personnel living under the same roof. You can have a mother, father, aunt, uncle, the grandparents, children. So you need to assess literacy. So the assignment doesn't really says that you need to assess the literacy of youngsters or middle-aged people or senior citizen. It doesn't say. So your focus will be to assess the literacy of the entire population. One example would be you could ask everybody to come to a playground and select one of these sampling techniques that you learned under these sampling techniques and just use it. That's possible. But what if you are more comfortable on visiting house by house and doing a survey? Let's say your village has 400 houses and your intended sample to assess this literacy level of this village would be to take only 20 houses. Let's say you only have 2 days to do this survey or one day. So you tend to select your uh, clusters based on your prior knowledge of this village. Let's say you have a household that has uh, people who are having the occupation um, with cultivations and agriculture, and another family with fisheries, and another family with industrial manufacturing, another family maybe clay potters. Okay. Now, when you go to that house, you will select 5 people from the same house to be included into your cluster or group. Now, in that example, the cluster is a one roof or a one given house in a village. So those kind of examples are very much evident in data collection, where you will see that depending on the easiness, sometimes rather than you try to do a detailed examination and detailed investigation onto all these 400 houses, rather you just tend to go to 20 houses representing the sample based on your knowledge. Uh, and importantly, you will only take one household from agriculture and fisheries and so on and so forth. So your sample will not be having repetitive values in that 20. So in some of these practical examples, you could see cluster sampling is being also used by statisticians. This is a slide that I've intentionally put to graphically illustrate you and give an understanding on the differences between the probabilistic sampling methods. The first one on the top left side, you could see simple random sample, where you can use a random number table or a random number generated based on some technique, and those numbers will be used to be selective to data points to be selected to your sample. Systemic sample, on the other hand, will use a systematic method. It doesn't necessarily have to be the first person, third person, sixth person. You may come up with an equation, let's say y equals 5x plus c, and then for the x value you could put 1, 2, 3, and 4, and then depending on the y value you can come up with the systematic method. It doesn't necessarily have to be it doesn't necessarily have to be the same interval. That's what I want to tell you here. But the sampling selection has to be depicting from a particular system or a pattern or an organized way. Third one we discussed called the stratified sample, where you tend to group your population based on a particular characteristic, and from those groups you could use a simple random sampling or probabilistic sampling technique to select some random data points to your sample. Last one that we discussed a moment ago is cluster sampling, where you could see you tend to put data points into different clusters based on your prior knowledge, and you will access an entire cluster and go and pick them into your sample from the population. So those are the mostly discussed 4 types of probabilistic sampling that we can see in the statistics jargon. At the beginning of the lecture, we discussed that if we could have the access to the entire set of population, that would be the best thing to do. But there are many limitations. Sometimes you tend to not have access due to cost, time, geographical limitations, physical boundaries, and various other variables which will come to challenge you to go and reach the entire population. Rather, most of the time, most of the statistical studies are going to be focusing on a sample. So that is why we have to depending on one of these sampling technique when we are conducting a research. So you may select some of the probabilistic sampling wherever applicable, or if you do not have access to some information on the population, you may also select non-probabilistic sampling also. But when you are trying to select a smaller set to be representative of the bigger picture, you will come up with some of the issues that you cannot avoid, but we will have to try to minimize them, having some idea on the sampling that having some idea on the sampling technique that you are going to use. So if you could ask me, okay, why can't we use 2 or 3 sampling methods together? Is that possible? I would say, oh yes, definitely. You are the researcher. I mean, there's no universal law saying that you will only have to select stratified sampling, and if you select stratified sampling, you can't go for another. I mean, if you could just go to this slide quickly. Under the cluster sampling, we discussed that one stage cluster sampling is where you will cluster everybody into different clusters and select a whole cluster into your sample. But from those clusters, okay, let's say in this given example, we have 5 t-shirt colors here, and we need to select 3. That is the first level. But for your final output, let's say you need to do you need to only study 2 clusters in this example. Now what are you going to do? You could stop it here, or again draw some random numbers, and you need to select only 1, 2, and 3 to be given to cluster 1, cluster 4, and cluster 5. And from these 3 random numbers, you select the first 2, the last 2. So you might end up being selecting cluster 1 and cluster 5 for your sample. So that's the 2-stage cluster sampling. Now here we are using 2 sampling techniques together. So likewise, you can you don't necessarily have to limit your survey to 1 sampling technique and finish it there. Okay. Well, let's discuss these issues one by one. Coverage error. This is where the sample is not representative of the population. That's the most common problem that we can come across these sampling techniques. Irrespective of your level, best mean try to be fair and using probabilistic or non-probabilistic or multiple techniques. Still, there could be a coverage error where the particular characteristic that you're trying to study will not be covered in your population in a fairly manner from the entire population being converted to sample. That's what we call as the coverage error. Second one is sampling errors. When a sample selected by a non-probability method, that is where if you use probabilistic methods, we discuss in the global level, you give an equal opportunity to be selected to the sample. But in the non-probabilistic techniques, we discuss that researcher or the statistician will have to use some judgment, selection, depending on the easiness or the accessibility to the data, to select items to his or her sample. So in such instances, you will not give equal probability to everybody. Isn't that so? So that's why this type of error occurs, where we name it as sampling errors. Okay. Third and fourth are important. These are being questioned in some of the past paper questions that we are going to discuss next also. The third one, the name given is the measurement error. Measurement error could occur because of incorrect or leading questions or data collection methods. Let's have some more detailed discussion on the measurement error. The broader idea of the measurement error is where the response differs from the actual value. That is the idea of measurement error. Let me repeat it. The response or the collected data differs from the actual data that you are intended to be collecting. Okay? A good example would be, let's say, uh, you're measuring some weight of, let's assume, some packeted items, let's say dal or onions or anything. Okay. Now your scale has a limitation of the minimum value being measured as 10 grams. Let's say you measure 5 items in a row. First item will give you 100 grams, second will give you 120, third will give you 140, fourth will give you 150, and the fifth one will give you 125 grams. That is the actual weight. But I define the rules of the game saying that you cannot have a minimum value more than 10 grams. So in that instance, your measuring device will either give that 125 grams a value of either 120 or 130. That is a classic example of the measurement error being coming into play. Again, students, now the measurement error, in some jargon you can discuss under two types also. We could say random errors and systemic errors. Now random errors are errors that is coming from accuracy or limitations of the device or the technology that you can use. That is exactly the same example that we used a moment ago. Let's say your measuring device will have a limitation of 10 grams being the minimum value. On the other hand, there are other types of measurement errors. Sometimes the literature says systemic errors. For example, let's say that scale that we discussed in the previous example of random errors under the measurement errors, that scale, let's say, is biased by +5 or +10 or +50 grams throughout the measurement. Okay, let's limit our example to +10 grams. So that means the very first data point 150, the actual value is 140 because our scale is biased +10. The second was 130, the actual value is 120. So you get the idea. So similarly, measurement errors are coming out of the incorrect measurement, or it could be again due to leading questions also. That means you tend to give some biasness towards the response when you are asking your question. Excuse me. That means, for example, let's say you're asking, what do you think that will, do you think will it rain tomorrow by looking at the sky? That means you tend to give an indication to your interviewee to look at the sky and think that if it is cloudy, he or she might say, okay, yeah, today it's cloudy, so tomorrow probably it will rain. Instead, if you just merely ask what's the probability of raining tomorrow, then he might not necessarily get that idea of leading his or her response by looking at the window. So on that instance also, measurement errors can occur because of the incorrect measurements or leading questions. Okay. The second aspect, similar to measurement errors, would be non-response error. That is due to respondents providing fraudulent or incorrect or not willing to give information or fail to collect the complete set of responses to one or more questions. Now here, the important thing is the measurement errors occurs because of the design or because of some biasness towards a certain point in collecting data. But non-response errors is coming because of the responses coming from the selected sample will not give the exact intended answers, maybe entirely, maybe partially. Let's say they are not able to or not willing to provide answers or tend to give fraudulent answers, false answers, biased answers. Those will create non-response errors. So those 2 points are very important, measurement errors and non-response errors. Sometimes we could see sampling errors also being discussed, but those are very straightforward. Coverage error again gives an understanding on not covering the entire population. Sampling errors is merely targeting on the non-probabilistic methods being used. The errors that is coming from the selection process that we do based on our judgments. But the measurement errors and non-response errors are kind of important in your examination questions that you will see in a while. Here, I've just put one example, one class example that you could see when you want to select your sample, what kind of limitations that you will be going through when you want to select the sample. Again, let's say these will be some issues that you will encounter when you want to do an actual study. Some of them would be criteria, but some of them would be limitations. First quadrant gives you an idea of the target population that I'm going to select. The example that we are going to cover here would be that my target population would be university students between age 25 to 35. Now, the consideration here, it says that we are focusing on some general characteristics or some particular or a specific characteristic to select a target population. Having set the target population, we may have some limitations when you come to the accessible population. Now, similar to my very first example, which we discussed today, of students who completed their advanced level examinations, like similar to that example. So when we are trying to do this survey of university students between age 25 to 35, your accessible population for your study may be the students who are attending the class today. Today you are going to do this study. So you might see students between, let's say, 18 to 40 or 45. Let's say this is an university which is conducting both bachelor's and master's classes. So the consideration that I'm trying to focus here is that you may come across some issues due to accessibility constraints. Inclusion criteria and exclusion criteria are where you could select a sample from a population depending on your choice. Now look at this filtration. You tend to have a specific filtration, international students. Now your population is 25 to 35 students first, then you tend to select a particular class, and there can be more students in that class, but your study always limits to the students who are attending to the class on that day. So you may have inclusion and exclusion criteria again. You may tend to choose international students for your study, and you may exclude some of the students based on another specific criteria. Here I'm going to focus on non-English speaking students. Why I discuss this case is that to show you that when you are going to do an actual sampling in a real world study or real world case, your sample will be extremely limited. Let's say you start with your, let's say you went to this university administration division, you spoke to them and you identified, okay, it seems that I could access at least 500 students in this university between age 25 to 35. But your actual sample will end up with 20. Why? From that 500 students, only 200 students have attended classes on that given day. Out of the students, only 50 international students, and out of the students, only 20 non-English speaking students. When you start your population with 500 population being trying to come to, let's say you want to select 50, unfortunately you have to end up with 20 due to uh, these practical constraints. And those are again some of the possible issues when it comes to sampling in real world. Okay, now that brings to the end of the theory section of this session. Before that, yeah, right. Okay, now before we move on to some of the examination questions, we could take a minute and discuss any doubts that you have with respect to sampling techniques or any general questions up to now on the classroom. Shall we just take a quick look on the past paper questions and then see whether you have any doubts? Is that fine? Okay, let's do so. Okay, these are some of the extra slides that I'm presenting today. I just put this just for your information purpose. Merely these are not facts that could be tested. These are again general sense and common sense, but yet again to complete the complete picture on the data and sampling, I just want to quickly touch upon some of the data collection methods that we could see in the real world. You could use some direct observations like CCTV cameras, speedometers, and you know, being present in a road and counting cars. So those are direct observations. Questionnaires and surveys. It could be common questionnaires in one aspect, or it could be electronic based data collection based on electronic surveys that we mostly could see on these days. Again, you could interview some person, one-to-one interviews. You could do some telephone based interviews also, a distance for distance data gathering. For example, if you want to talk to some of the students in India, you may have to use some teleconference or Viber, WhatsApp kind of a technology. Lastly, you could also use a thing called focus group discussion, where you tend to get a set of people into a room or a particular place and give your question and get their responses based on previously known characteristic. So these kind of methods you could use to collect data. Having discussed that extra theory part also, let's see how your examiner is keen to test your knowledge on some of the examination questions. Can you see my screen, everybody? Okay. Okay. The first question, again, important to identify that uh, with this sampling techniques being discussed, now we have completed one out of the 11 subject areas that we are discussing under this course curriculum. Okay. But interestingly, if you look at the past paper questions and do a bit of an analysis and see whether what sort of questions being tested under this very first, second, and third areas, You might not necessarily see an entire question, entire 20-mark question that comes from this knowledge. Yet again, this gives a very fundamental uh, establishment on your knowledge base when we discuss future sections such as probability, linear programming, uh, stocks and bond returns, where you will always start with a sample being collected, with a set of data being selected, so on and so forth. Interestingly, examiners tend to question on uh, open-ended question and answers like given here. Especially in the very recent papers, you could see under question number 8, where you have four open-ended questions you are invited to answer with 5 marks each, which will give you a total of 20 marks. You could recall we discussed under the last lecture very basic things like qualitative data and quantitative data, primary and secondary data. Now, similarly, the knowledge on these sampling techniques are also appearing on and off on this last question. Okay. Now, when we complete the third section also, you might be equipped with answering the full 8 question number 8 question in your past papers, couple of past papers, because mostly these are being tested again and again, the same thing, the same subject area, because that sometimes students tend to misunderstand or misrepresent the knowledge when you're trying to write answers. So that's what I said. The slide set that we have designed for your perusal is in a very short note oriented manner. I didn't want to categorically put more data where you'd have to read a lot. Rather, a couple of lines which will give you the very basic idea for you to remember it in a long time. So from your end, what you could do is to write some of the classical examples of your choice, either stuff what we discuss here, or if you do some browsing on internet, you might find different examples, these sampling techniques for you to remember. So take a moment, write down some of these examples. So it will become very handy when you're trying to write a full example in a explanation like given here. So amidst from this being tested in question number 8, sometimes you could see one or two sampling techniques being tested in some of the MCQ questions also in a couple of past papers. So that gives you a hint that you need to have a basic idea of how to identify the differences between each of these sampling techniques and your first lecture knowledge, so that you can easily tackle all the questions. Okay. Let's take a moment and see what sort of questions being tested here. Question number 8, compulsory, not compulsory, it's elective. Part number 4. Now this question says, statistics involved in various types of data collection from various methods and sources. Briefly discuss the following concepts related to statistical information. Okay. We have been asked to describe, or rather discuss, simple random sampling and stratified sampling. Pretty easy now. Simple random sampling is where you give an equal opportunity to all the items in your population to be selected. How do you define a simple random sampling? It's merely by giving them a random number to be chosen. By using a random number table or a random number generator, you could give some data points, and those data points can be handpicked for your sample. You could give 1 or 2 examples also. Stratified sampling, define them into different stratas. From the stratas, you could select items based on probabilistic or non-probabilistic. That is where your memory tend to tackle a little bit, I would suggest. If we just once again go through our notes, we discussed that stratified and quota are very much similar, but in stratified, you tend to use a probabilistic method. In Quota, it doesn't necessarily have to be. Okay, so as long as you write an answer depicting that stratified is, you cluster them into different stratas or groups based on a particular characteristic and use a probabilistic sampling method to select your sample that will give you sufficient marks, and put up some examples also. Okay, this is a question that we are discussing on 2019 September. Now students, question number 1 is compulsory, which we discussed on last week also. So you don't have a choice, you have to write answers to all 10 parts. This is question number 1, part number 2. Let's read the question. In a sample survey, every 10th individual from the list of all employees of a factory are planned to be interviewed to find out their views on the present retirement benefits. The name used to be described in this sampling method is, would like to take a guess and reply in the chat. A, B, C, or D. You're going to select every 10th individual from the list. Every 10th individual from the list. Those are the important keywords. Okay. Some people are getting it right. It is the systematic sampling. Similar to our class example that we discussed, where we want to select first, third, sixth, seventh, so on and so forth. So that shows you the examiner is keen to know the basics only. Do not answer. It's very difficult for the examiner to design a question to give a set of samples and ask you to define a sampling method. It's a bit of an impractical thing at this examination. Rather, the examiner will be very keen to ask and seek the differences and similarities under these sampling methods again and again. Let's look at this example, 2019 March. Okay, I hope I give you the answer here. B, systematic sampling. Okay. This is again coming from 2019 March nearby paper. Look at question number 8. Statistics. Let's read from my notes. Statistics involving various types of data collected from various methods and sources. Briefly discuss the following concepts related to statistical information. We discussed part number 3 last week. Now you could answer part number 2 and part number 4. Let's look at part number 2. Simple random sampling and stratified sampling. You could recall, it's the similar question which we answered a moment ago. Simple random sampling, where you give equal opportunity to all the items to be selected to your sample based on random number generation method. Stratified sampling, cluster them into stratas, used a probabilistic method to select your sample from the population. Look at part number 4. Measurement errors and non-responsive errors in conducting surveys. This is one of the most favorite areas of the examiner. Measurement errors. We discussed that it could be random or systemic, based on the nature of the error being occurred again and again, or towards one data point being erroneous. So the idea of measurement error is that actual corrected data differs from the collected data differs from the actual data point. Non-responsive errors occurs because of the sample does not give you or does not give the correct response due to various reasons such as dislike, non-willingness, not having a comfortability to express their views, many things. Indicate some examples for your answer to be completed. This question again tested in 2018 September. Yeah, same explanation. Statistics involved in various types. I don't have to repeat. Look at what is being questioned: measurement errors and non-responsive errors in conducting surveys. So as long as you have a bit of a short note on this area, you could see that easily you can score 5 marks here. And provided you have your knowledge on first two lectures and the third and fourth, you can easily tackle 20 marks. You might not get 20 out of 20, depending on your level of explanation. You might end up with maybe 15 or 16, even if you write to your level best, because the marking examiners will find your answer may be marginally deviating from the answer, and it might tend to a deduction of 1 or 2 marks. But provided that you could write this in a successful way, how many marks do you more need to get to your 45 point? Maybe 2 or 3 more questions than at your level best. Isn't that so? So question number 8 is going to be one of the easiest areas that you can tackle with your first couple of lectures knowledge. Let's look at this question. 2018 March. Again, the same explanation, statistics involved. Look at question number, subpart number 3. Simple random sampling, stratified sampling. Again, you could easily see it's a repetition, right? Now I want to take all of you to take a moment and answer this question. This is coming under question number 1, part number 6 of 2017 September. If you have the answer script, please don't look into the answer right now. But let's discuss and come to a conclusion and find the answer. I'll read the question for you. Suppose you are performing stratified sampling on particular population and have divided it into strata of different sizes. You're going to do a stratified sampling. You can now make your sample selection by A, selecting a random and equal number of elements from each stratum. Now the important thing to highlight is you have divided into strata of different sizes, okay, not equal sizes. Part A says you're going to select random or equal number of elements from each stratum. Part B says by selecting equal number of elements from each stratum and weight the results. Part C says selecting number of elements from each stratum proportional to their weights in the population. Examiner is asking which of the following is correct for above statements: A and C, B and C, all, or only A. Take a moment and let's try to find the correct answer. What do you think? You have a strata, different sizes. That means, let's say 10 on one strata, 7 on the second strata, third strata you may have 8, so on and so forth. Now you're going to make your sample selection by A, it says selecting at random or equal number of elements from each stratum. B, it says selecting equal number of elements from each stratum and weight the results. C, it says selecting number of elements from each stratum proportionate their weights in the population. Okay, we have some answers on A. Okay, in the interest of the time, let's have a broader discussion. What if we, okay, now just look at the answers below. We have to be picky here on statement number A. Okay, it says only A and C are true, Or in the answer number C, it says all are true. That means A should be true. In the answer number D, it says only A is true. So if we can come to a conclusion on statement A, that means we can select an answer. A says selecting at random or equal number of elements from each stratum. Now students, the important thing is the stratas are different in sizes, isn't that so? So let's say in our first strata we have 10 items, second is 7, and third is 8. What if we select 3 from each? It will give you a non-equal or probabilistically indifferent chances for different stratas, isn't that so? So in statement B and C, what it says is, it's the same thing, said in different manners. Statement B says selecting equal number of elements from each stratum and weight the results. Statement C says selecting number of elements from each stratum proportionate their weights in the population. Now C seems to be the best one. How about B? Selecting equal number of elements from their stratums and weight the results. That means you select 3 from each stratum, but when you come to the results, you tend to do a weighting based on the weights of the individual stratums. So the judgment here, the answer given is B. Only B and C are true. Why? If we merely go with answer A, that means we are giving the stratums a non-equal probabilistic opportunities to be selected. Okay, that's about question number 6, part question number 1, part number 6. Okay. Okay, I have many more questions being extracted from the past papers. We don't necessarily need to discuss all, but just for the completion sake of the session, we'll just briefly go through them, because I'll show you it's the same questions being asked a couple of times again and again. 2017 September, you could see examiner has tested your knowledge on this should be part number 4, cluster sampling and stratified sampling. I would see you've been tested heavily if we tested your knowledge on quota sampling and stratified sampling. That is where you have to be exactly careful. Here, these are very straightforward questions. 2017 March, you have one MCQ question. What is the best sampling method to be used in survey related to wages in apparel industry, where there are male and female workers? What do you think? Stratified, systemic, quota, or random? We'll keep that question for a little while, and let's see question number 8 also. Systemic random sampling and stratified random sampling. You have to explain. 27th March, but it will just take it for a while. Look at the other one. Question number, sub-question number 4, measurement bias and non-responsive bias encountered in sampling situation. See, so similar questions tested again and again. Now look at question number 1, part number 4. Take a moment, read the question, and select an answer for our discussion. Question says, what is the best sampling method to be used in a survey related to wages in apparel industry where there are male and female workers? There are 4 answers. Stratified sampling, systematic sampling, quota sampling, random sampling. I'll take answers from one by one. Random sampling. What if we take random sampling? What will happen? Here it says male and female workers are evident in the factory that we are going to interview, right? What if the random numbers that we are going to select will only give you a biasness towards males or females? It will give you an indirect direction, isn't that so? About quota sampling, okay, that seems to be a fairly good method. We keep that aside. What about systematic sampling? That means you tend to put them in a line, or using an equation, you tend to select an opportunity. Still, it will give you an biasness. What about A, stratified sampling? This is a battle between stratified sampling and quota sampling. Okay, we could eliminate answer B and D. Out of stratified and quota, you would see the question gives you a leading indicator. That means that there are male and female workers in the population. That means you best would be to, stratified and quota is a similar. We discussed the probabilistic and non-probabilistic technique. Non-probabilistic mean quota and probabilistic mean stratified. The best is always probabilistic, where you can go for answer A. Stratified sampling, you put everybody into two stratas, males and females, and then randomly select uh, people for your study. Last couple of minutes, I'm taking a little bit time of here today because we started the class a little later. Look at question number 2016 September. Statistics involved in various types of data. Again, similar explanation. I'm asking you to compare and contrast probability sampling techniques of simple random sampling and stratified sampling. You can do a fair answer now with your knowledge. Measurement errors and non-responsive errors in conducting surveys. That's what we discuss again and again. So with that, students, we can wrap up today's lecture, and thank you for your time. If you could bear with me for another minute or two, if anybody is having a problem to be discussed here, we could open the floor for your discussion. Or you can use the chat feature in the Google Classroom. I hope mostly today's lecture is pretty much straightforward. We do not have much computations. The interesting stuff, computations, numbers are coming in the latter. Okay, thank you for your time, and